Vocabulary definitions. We're talking about average rate of change and slope. Okay. The rate of change shows the relationship between two changing quantities. How fast something changes. This is a big deal. This is something that is studied an awful lot in math, being able to analyze how something changes, how fast it's changing, when those changes happen. Calculus is all about change. How to find change, how to figure out change, how to figure out what that change tells me. That's what it is. Calculus is all about trying to figure out how fast something is changing or what the rate of change is. Okay? We deal with that here in a much simpler format, but we do have rate of change in here. Okay? Slope, we'll talk about slope of lines. Okay? Slope is the rate of change. The slope of your line is the rate of change of whatever we are graphing. It is the vertical change over the horizontal change. It is the rise over run. I'm sure you've heard that before. We use M for slope. M is the letter that we use for stand for slope. Wherever you see an M in what we're talking about coming up, that means slope. M is your slope. Okay? And your slope is rise over run. We do have one formula. It is an important one. Make sure you get this down. If we have two pairs of x and y coordinates, and we will be doing this, your slope is the change in y over change in x. Okay, y minus y over x minus x. Specifically what we have here, y2 minus y1 over x2 minus x1. It is extremely important for you to understand the 2 and the 1 are subscripts. They have no effect on value whatsoever. You're not squaring, you're not square rooting, you're not doing any of that stuff. The 2 and the 1 just tell us that we have two different y coordinates and two different x coordinates. Subscripts have no effect on value. They just let us use the same variable more than once. Okay, so we can have two x's. One of them is the first one is the second one. That's what the subscripts do. They just let us have two x's or let us have two y's. They have no effect on value. You'll notice over here on the board, I have this written down over here again. You will be using this a lot. It is important to note that it is always subtraction. Y minus y, x minus x. The one that I have written on the board in here, the stuff in black never changes. The stuff in the blue is what changes. That's what you plug into it. Okay. Now, there are a couple of specific slopes that we want to talk about. First one is if I have a slope where I have no change in my rise. Remember, and you may remember this from before, we'll get into it again. You may think of slope as rise over run. Okay, and how do I remember which one's which? You rise up and down, your y's go up and down. So your up and down goes on top, you run back and forth, rise over run. So your x's go back and forth, your x's, your change in the x is what goes on the bottom. Rise over run. You rise up in the morning and you run back and forth to school. That's how I remember. So when I'm looking at this one here, this slope here, I have no rise, it doesn't go up. Okay, there's no change in how much it goes up and down. It only has change going back and forth, no change going up and down. That is a zero slope. If I have 0 divided by a number, that is a zero slope. A zero slope is a horizontal line. Horizontal lines have a zero slope. And there is a difference between no slope and zero slope. Zero is a quantity we can measure. No slope means it cannot be measured. So if you see no slope does not mean a zero. Zero does not mean no slope. There's a difference. You can measure a zero slope. It's a flat line. Now, if instead we have the line goes up and down but does not go back and forth, we have a number divided by 0. You are never, ever, ever allowed to divide by 0. So we have a slope with no run, with a rise but no run. That is an undefined slope. That is what a vertical line is. If you have a straight vertical line, It has an undefined slope. Okay, because there is no run, there's only a rise. It goes up and down, it does not go back and forth. Okay, you're going to need to memorize those, know those. Questions? Okay, so finding rate of change using a table. So I have over here an XY table. Yep. Nope, River. So you look at the first one, you have a table of values. And what you want to do is you want to figure out the rate of change from the table of values. And the rate of change is your change in your y's over your change in x's. In this case, it's our distance. How does our distance change over how does our time change? Okay. So the first thing I want to look at is this number a change? How much does it change? When I go from 260 to 520, how much does it go up by? Do you have calculators? You should. I know some of you have your own calculators.
Yeah.
No, you can wait. You can wait. Okay, 520 minus 260, what do you get? How much? 260. Okay, so my change, the amount that I go up here is 260. Is it the same going from 520 to 780? Does that go up 260 again?
Yes.
Okay. From 780 to 1040? Does that go up the same amount there? Yeah. How much does this one go up by from 1 to 2? From 1 to 2 goes up 1. Okay, when I go from 1 to 2, how much am I increasing? I'm increasing by 1. Come on. Okay, when I go from 2 to 3, am I going up by the same amount? Yeah. If I go from 3 to 4, am I going up by the same amount? Yeah, I'm going up by the same amount. So my rate of change is constant. The amount that I'm increasing in each column is the same each time. My rate of change is a constant rate of change. In this case, it's 260 over 1 or 260. Now, rate of change is often used to measure how fast something is happening. Gentlemen, stop. Okay. In this case, what are the two things we're measuring? What is this side measuring? Distance. In what units? Feet. So I'm going up 260 feet. What am I measuring here? Time in minutes. In minutes. So I'm going 260 feet per minute. That is what the marching band is traveling at, 260 feet per minute. That is a rate of change, how fast something is changing. Okay, your speedometer when you're driving in your car, your speed that you're going, that is a rate of change. Okay. Now, much of your homework, or classwork I should say, is like these next couple of problems. So you're going to have a line on a graph, and you're going to have to figure out the slope of that line. Now, first thing I'm going to talk about, ignoring the slope itself, as I'm going from left to right, because we read graphs just like we read a book, we go from left to right. Is this one going up or going down? This line is going up. If it's going up, then it has a positive slope. The slope is going to be positive. This one, as I go from left to right, goes down. It has a negative slope. Okay. So your answer should be positive or negative accordingly. Now, when you're doing your graph, when you're looking at this one already has it measured out. Here's what you need to do. Pick any 2 points that are on that line. When you do that, pick points that cross at a grid place. Do not just randomly pick 2 places anywhere you want, but pick them where they cross at a grid. You don't want to, for example, pick right here because that doesn't cross at a grid. You want to make it easy to count. You don't want to be dealing fractions when you're counting things. So you can pick any 2 points. This one already has 2 points picked out. Your one in your classwork will not necessarily have 2 points picked out. When you do that, as you're going from one point to the next, you need to figure out your rise. You need to figure out your run as you're going from one to the next. So using these 2 points that are already on here, how much do I go up? How much do I go over? And remember, your slope is your rise over your run. How much you go up over how much you go over. So I'm going from this point to this point. How much do I go up? I go up 2 units. So my slope on this one is 2. And how much do I go over? 3. 2 over 3. If I use the other one, I do have the 2 points there, but I can use any 2 point or it's 2 points where it crosses. So for example, actually these ones are very hard to do on this one other than the one it has. But I can go from one point to the other, and it doesn't matter which one I do first. I can do the rise or I can do the run first. For example, if I wanted to, I could go, okay, I'm going to go over this way and do my run first. And that would be going over 1, 2, 3, 4, 5 units. And then going down, so I go over 5. And then I go down 1, 2, 3, 4. Is down positive or negative?
Negative.
Negative. So my slope is negative 4/5. Easy peasy. Pick 2 points. Figure out your rise. Figure out your run as you're going from one to the other. Draw a little triangle. Slopes are always fractions or whole numbers. No decimals, no mixed numbers. You do not say, oh, that's 4/5, that's 0.8. No, you do not say the slope is 0.8. When you're figuring out slope, you have it as a fraction, either improper or as a whole number. No mixed numbers. You do not have a slope of 1.5. That's not what we do. That's not how you do it. Okay? Questions so far? Okay. Finding a slope using points. Now, you could, because you have 2 coordinates here, you could use the 2 points that are on the line. You use those coordinates or pick any 2 points on the line and use them if you wanted to do that. Okay. But let's say I'm not given a graph. I'm given 2 points. I want to know what's the slope of the line passing through those 2 points. I use the formula that we have for finding slope. Change in y over change in x. y2 over y1 minus y1 over x2 minus x1. Once again, the stuff in black never changes. The stuff in green is what you put in. Now, in order to make this easy for yourselves and easy to keep straight, label the 2 coordinates. Okay. So, remember, it's x and then y, so x1, y1, x2, y2. If you label the 2 coordinates you have first and then plug them into the formula, it goes a lot easier. You're less likely to make a mistake. And plug in the numbers. So, y2, what goes here? -2. Okay, y1, y2, so I put in -2. What goes here? 0 from the y1. What goes here? 3, the x2. What goes here? -1. You might want to put, if you have a negative in there like that, put it in parentheses. And then you simplify. Okay? -2 minus 0, well, anything minus 0 is just what you started with. -3 minus -1, remember when you have subtracting a negative, make it addition. -3 plus 1, or sorry, 3 plus 1 gives me 4. And then what do you always try to do to fractions? Always reduce. So my slope would be -1/2. Now, what if you had the numbers reversed? What if you had, this is x2, y2, and this is x1, y1? It doesn't matter. You'd still have the same numbers. If you put them in differently, reverse the points. 0 minus -2 over -1 minus 3. 0 minus -2 ends up being 0 plus 2, which is 2. -1 minus 3, that's -4. You still get -1/2. It doesn't matter which y-coordinate and x-coordinate comes first. As long as whichever one is first in your numerator, the matching x is first in your denominator. The most common mistake, there are two very common mistakes. One, students like to put x's on top because they come first, so they go on top. That's wrong. Your y's go on top. The second number in your points is what goes on top. The first number goes on the bottom. Okay. Careless students will have, oh, here's my 2 y's, here's my 2 x's, without making sure they line up properly. Usually the most common one is having that upside down. Make sure you don't flip it over. Put the y's on top, the x's on the bottom. Remember, your y's go up and down, your x's go back and forth, you rise over your run. Most common mistake. The other one that students do, and it drives me nuts because I don't know where it comes from, they take the first set of coordinates and subtract those 2 points, and the second set of coordinates and subtract those 2 points, without actually doing anything close to resembling what the formula is supposed to look like. Just don't do that. Any questions? Okay, today's classwork is all about